This is the Calculus Pre-Lecture Series. I'm Caitlin Murphy, and this podcast is on continuity. We define a function to be continuous at a point a if the limit as x approaches a of the function f of x is equal to the function value at a, f of a. We can break this down into three main parts. First, f of a must be defined. Second, the limit as x approaches a of f of x must exist. And third, the limit as x approaches a of f of x has to equal the function value at a, f of a. And we say that a function is continuous if it is continuous for every point a in its domain. So to get a better picture of this, we'll actually look at some counter examples to this definition. So as a reminder, we have those three properties up in the left-hand corner. And we'll consider the graph here in the middle of the screen. Notice our function drawn here in blue. So at the point x equals a, we can see that our function value is not actually defined. We have a hole there, and it's not defined for any value at x equals a. So this function does not abide by the first property that f of a must be defined, and therefore it is not continuous at x equals a. We'll consider another one. So in this case, we still have a hole on the function at x equals a, but our function value is defined. It's just above L. But notice that the limit as x approaches a of f of x is L, but our f of a value is not L. So we actually are not abiding by the third property, that the limit as x approaches a of f of x is equal to f of a. So, in this case, this function is also not continuous at the point x equals a. One last counterexample. So here we have our function value approaching from the left. The limit seems to be the value f of a. But there is a jump there, per se. So the function values approaching from the right side of a are actually not headed to the same value as the function values approaching from the left of a. So that limit at x equals a, as x approaches a of f of x, does not exist for this function. So we're not abiding by property 2, that the limit as x approaches a of f of x must exist. So this example is also not continuous. So, as a reminder, if we have a function that does satisfy all three of these properties at a specific point x equals a, that function would be continuous at x equals a, and if we have a function that abides by all three of these properties at every a in its domain, we would say that that function is continuous.